Okay, so I think we can get started with the first session. GITAM's Masters Data Science 23rd April. Let's go. I'll hand on to Tarun and Krishna to continue.
Oh, I can hear your voice.
Say it again.
Can you hear me now?
Yes, I can hear it.
Okay, nice. So the first question you posted is, what is the difference between perceptron and neuron? So basically, neuron is it's like the fundamental unit of the actual human brain, but a perceptron is like an artificial computer version of a neuron. It's inspired by the human brain's neuron, but it's not an actual neuron. It's actually programmed. And so when we talk about artificial neural networks, we make neural networks out of perceptrons, right? They're like artificial neurons.
Actually, like Tarun, just a doubt. When I searched in research papers, the first one who implemented this perceptron, he said that it is an algorithm working on some different kind of use case. And in various research paper, they're saying that perceptron is a single layer. Like, there is like confusion on that.
As far as I know, a perceptron is okay. So basically, what you're saying is perceptron is like a whole layer of neurons.
Yeah.
Okay. Yeah, I think that's another way of looking at it, because if you've heard of MLP, right? Multi-layer perceptrons.
Yeah.
That's basically what it is. It's multiple layers of neurons, one after the others, connected to like fully connected to each other.
That's what we call as a neural network, which is.
Yeah. So what I'm saying is they're not fundamentally different things. It's the same idea. Just multiple neurons in like one layer, and then one layer like followed after the next layer, like in a sequence. It's more of a terminology thing. It's not really there's no real technical difference. People just refer to them interchangeably. Like sometimes people call it neuron, sometimes people call it perceptron. It's not really a big deal.
Okay, gotcha.
Yeah, I'll just summarize. Perceptron is a mathematical equivalent of a neuron. It's a representation of neuron in mathematics or in the AI world.
Okay.
Does it answer your question, Nani?
Yeah.
Okay.
Satisfying the answer.
Okay, I'll go to the next question. Please suggest some materials like PPTs, PDFs, etc. of math behind convolutional neural networks. I would suggest, if you want to understand convolutional neural networks, you just search on YouTube. You'll find some really good resources to understand anything to do with neural networks.
Okay.
Have you heard of Andrewing?
Yeah, in Coursera, I'm referring the courses of Andrew and G.
Yeah, I think Andrewing is the best way to learn anything to do with mathematics for deep learning. He's really good at that.
I'm going to send you one of your presentation this regarding this artificial neural network. I looked into your math in that. I understood that. Like it's like an abstract thing. I had to go deeper into that.
Okay.
So, and like a lot of information we have on the online web. So it's like a big deal to get the right information. So that's why I asked for any presentations or else.
Yeah, those slides have a lot of information. It takes to just try to find which part of it you want to read, right? It's a lot of things to do. So you want more resources for convolutional neural networks other than Andrewing, or
yeah, I watched Andrew and G videos also. Like I'm not somewhere in like somewhere kind of resources I need to clearly understand the things, because deep learning is depending on the perspective which we think, like such kind of thing deep learning is. lot of confusion is there. So I need a lot of resources to understand a lot of things.
So I would think maybe beyond the basics that Tarun is suggesting from Andrew, and maybe picking up some kernels at Kaggle to understand the basics of CNN, that might be helpful. That will give some practical perspective of the basics that you learned.
Do you know
Yeah, sure.
you know Kaggle, Nani?
Yeah, I'm following you also.
Thanks for following me.
Yeah.
So yeah, Kaggle, Kaggle is a really good place. Like, yeah, you just need to search for people who wrote code on CNNs. There are a lot of people who make tutorials on Kaggle. So like, you can just go to Kaggle and search CNN tutorial.
Yeah, they are very very basic things. And I understood the basics of this all need.
They're too basic for you.
Yeah. And I also posted some like I'm active in some discussions. I posted few questions and I get some answers. I got some answers. That's okay with the Kaggle. So any practical kind of resources you can, if you can, you provide the resources.
Off the top of my head, I'm not sure what you can do for CNNs. Do you know anything like like very practical or higher level kind of CNN material?
Actually, I know like taking the like from my knowledge, first we take the image and convert it into some sort of like mathematical values or rescale them and do a lot of convolution, max pooling. These all kind of stuff that I know.
Yeah, I think in CNNs, the best way to go about it is more than the modeling part, understanding the various data sets that are available, which can be very different. So maybe offline, we can share the list of the data sets that are quite commonly used in CNN's world. So
Yeah, I
because
started working on this cat and dog data set on Kaggle uncle. So first thing is I had to like understand the data set. The first thing is pre-processing step. Like for grayscale, we will use one into by one matrix. In RGB, we'll do 3D such things. So I'm just learning the things now. CNN about.
Okay. I think what you need is do you know what framework are you using for training convolutional neural networks? Are you using TensorFlow, Keras, PyTorch?
Oh yeah, only TensorFlow and Keras.
TensorFlow? Okay,
Yeah,
I think TensorFlow's website has really good tutorials for convolutional neural networks.
I'm
Um,
following the blogs of TensorFlow. Tarun.
Yeah, so their website has really good tutorials for beginners and advanced people. So you will find things like, like you said, basic things like classifying dogs from cats, or you might something like bounding box prediction, like being able to draw boxes around all the objects in a picture. So if you have like a picture of a kitchen, it can draw a box around the bananas and another box around the apples, things like that. So there are a lot of advanced convolutional neural network things that you can do, and all of them are on the TensorFlow website. If you want, I can send you some links.
yeah,
Um,
Yeah, okay. Then.
yeah. So let's wait for a quick minute, and we can get the actual link for these advanced tutorials.
Yeah, okay.
You can share the URL here. Click on this chat. Yeah, put the URL. And then
URL
Yeah.
in the chat. Okay, yeah. So here, if you click on this link, you'll see a lot of different options for CNN tutorials. Um, you'll see image classification. You'll see object detection. So this might be a nice place to learn some learn more in depth, because if I understand what you're saying correctly, you want to go beyond like basic,
Yes, that. Yeah.
kind of stuff, basic like like digit recognition and all that. You're tired of that. You want a little more advanced stuff. This is good for that, because you said you're doing TensorFlow.
Yeah, thank you.
Okay, cool. So
Like, before building the model, we'll use the hyperparameter tuning. I think that's a good thing, because it will tell us which model is best using different kinds of, like, which like.
Can you say that
Which,
again? Sorry, I lost you in the middle.
Yeah. Before the building the model, we can use hyperparameter tuning. Yeah, because it helps us a lot while building the model. Like, it suggests us how many of layers we have to use.
Yeah, that's really important.
And then, like, there is a, like, I want to know, like, actually we have a image which is like, in that we have one pixel which is of 16-bit. How this like 16-bit of image is converted into the mathematical value?
So you're saying, how do you take the
Like, how the system which provides the input for the TensorFlow, which backend, they code something, no? How this works?
Okay. Okay, I understand your question. So basically what you're saying is, you have the image has a lot of pixels, and you want to understand how those pixels are processed in the CNN. Like, how does it understand the image? Okay. So basically, an image, what happens when you actually when you actually download an image, right? The pixels that you're talking about, they're just RGB values, right? Like I think you were explaining earlier. So each pixel has a red channel, a green channel, and a blue channel. And so with those three numbers, you can represent one pixel, right? And so if you have a 16 by 16 image, you have 16 into 16, 256 pixels, right?
Yeah.
And each pixel is three numbers, right? So like it can be like red 100, blue 70, and green 200, something like that. Any values between 0 and 255, correct?
Yeah.
So 256 pixels, and each pixel is three numbers. So that 256 into 3, which is 768. Those 768 numbers represent that image, right? And those are the numbers that that the CNN will see and process.
Yeah.
Does that answer your question?
Yeah, I got you.
It's a huge like matrix of numbers, basically. At the end of the day, it's nothing special.
Why we actually use the transpose of weight actually? Why we use the transpose of weights? Why we had to use that transposing the weights? Weight matrix.
Can you give me more context? Like, what algorithm are you talking about, or what use case? Do you have any specific example in which you're transposing?
Like, for example, like if you send the data to the neuron, which converts, like using the activation function, which converts.
Can you say that again?
Am I audible now? Hello.
Yeah, I can hear you now.
Okay. So generally, what the neuron do is that we multiply the input with the weight, and we add the bias. We send it to the activation function, which does which fire up or shut the neuron. So while doing that, like in image classification only, like we have to transpose the weight matrix. Why we have to do that?
Okay. I understand your question now. So if I understand correctly,
like transposing involves a lot of computation. So why we have to do a lot of complexity?
Makes sense. So basically, if I understood your question correctly, is like in a neural network, when you're trying to calculate the values for the next layer, you multiply the current layer with the weight matrix, and then you add a bias matrix, and then activation function. That's what you're saying, right? And why do you have to transpose the weight matrix is your question.
Yeah.
Okay, so basically, in order to multiply a matrix with a vector, so the matrix here is the weight matrix, right? W, and the current layer is a vector X. So if we want to get the next layer from the current layer X, we have to transpose the matrix and do matrix multiplication with the vector. Why?
Okay.
Because for the multiplication to work, we need the dimensions to match of what we're multiplying.
Okay.
Okay,
If we, yeah, we'll for example, all the input image pixels will convert into single dimension vector. No?
yeah. So
Input vector. I'm talking about input vector. We'll multiply with the weight vector. Like you're saying that to match with the like dimensions, we have to transpose the matrix. Is that what you're saying?
yeah, because if you want to multiply a matrix with a vector, the number of columns in the matrix needs to match the number of entries in the vector, right? Like if I have let's say I have a matrix and a vector, okay?
Yeah.
How do you multiply if you have if someone gives you a matrix and a vector, how do you multiply them? You take the first row of the matrix, right? And then you multiply it with a vector.
Yeah.
And that gives you the value, the first number. And then you go to the second row of the matrix, row number 2 into vector, that gives you the second value. Row number 3 into vector, third value. Row number 4 into vector, fourth value. So for that to be possible, right, each row needs to have the same number of values as the vector, correct?
Okay. Hmm.
And each row has how many numbers? That's given by the number of columns,
Yeah.
correct? And that
Yeah.
needs to equal the vector, the number of values in the vector. If you do not transpose, right, then it will be opposite. It will be opposite. The number of rows will match. We don't want the number of rows to match. We want the number of columns to match. So that's why we reverse it so that it matches the dimensions and the multiplication is possible. It's more of a mathematical thing. It's not basically what I'm saying is it's not anything to do with AI. It's just to make the multiplication possible. Because if you don't transpose the weight matrix, you cannot do any multiplication.
Yeah. I got you.
Understood?
Yeah.
Okay.
Like,
And if you
why we have to use the padding, especially?
yeah, continue.
Sorry?
Yeah, I was just saying if you want to understand more about the the weight matrix and transposing and all that, you can refer to the slides that I wrote. That's explained in a lot of detail in those slides. The whole transposing the weight matrix and all that.
Yeah. In back propagation, you like in your slide, like you're doing partial derivative using chain rule.
Yes.
Yeah, like you consider only like for example, you said in that like you said to consider that all the weights and bias to be a P matrix. Like,
You
you
consider
remember
all the weights and biases to be?
a matrix which is called a P matrix P.
Yeah.
Like just abstract thing. Like, yeah, just understand the chain rule and it's okay.
Yeah, it's just I just introduced P as a new variable to explain how the chain rule works.
Okay.
Because ultimately in backpropagation, what we're trying to do, what we're trying to achieve, is to find the partial derivative of the loss function with respect to all the parameters, right? So we want to find like if the loss function is j, we want to find dj by dp, right? Compared to
dj by dz.
yeah. Why? Because we need that those partial derivatives to update our parameters and move on to the next step, right? That's how the model learns from the data.
Yeah, I doubt in that the like all this updation will done in one pass.
No,
Step by step.
it's done in multiple passes. So this whole dj by dp thing is done again and again and again. So like you get one batch of data, like let's say 100 images. You like you said, you're doing that cats and dogs problem, right? So let's say you have 100, you just take 100 images of cats and dogs, pass through the neural network, right? then back propagation, and then update the weights. And then again, you get the next 100 images of cats and dogs, pass it through the neural network, update the weights, so that you keep like repeating that process recursively until your model has learned has learned enough. It's not just one pass. You have to keep doing it again and again.
I'm asking that all this chain rule is done in one pass under the hood.
Oh, you're talking about calculating the gradient with the chain rule.
Yeah.
Yeah, that's
From
done
the
with.
last slide to the first slide, it doesn't one pass, or else between the layers.
There's one pass that goes from the start to the end of the neural network, from the front to the back, and there's one propagation that goes from back to the front. So forward propagation is one step from the beginning to the end, and back propagation is one step from the end back to the beginning. So you come back to where you started. So it's totally two propagations.
Okay.
So it's like you run to a destination and you come back to the start again, and you keep repeating that.
Yeah.
Okay.
So Nani, do you want to share in the chat the link that you have for that presentation that you both are talking about? That way, the other people who are seeing this recording, they get to see those slides as well. Whatever the link that I shared with you.
Yeah, I just log into WhatsApp.
Yeah, just put in it. Yeah, thanks. Can go on to the next one.
Okay, so I'm moving on to the next question that you posted, right? What is the need for DCNN when CNN and backpropagation works?
Yeah.
Okay, so DCNN stands for Deep Convolutional Neural Network, right?
Yeah.
And DCNN is not fundamentally different from CNN, right? It's basically just a CNN, but with more stacked layers. It's a deeper network.
Yeah.
That's why it's called a deep CNN, right? So in more, if you're solving simple problems, right, like classifying MNIST handwritten digits, or you're classifying dogs and cats, you may not need that very deep CNN, because you're not solving a very complex problem. The images are not that hard to classify, right? But if you're solving a much harder problem, like for example, taking a photo from outer space and recognizing whether it is which planet it is, like if it is Jupiter or Saturn, that's a much harder problem, right?
Yeah.
You need a model that can understand much more intricate and complex details in the image compared to dog or cat, which is much simpler thing to do. So in that case, you want to use a CNN, but you want it to be capable of handling more complex images. In that case, you use DCNN. It's fundamentally the same as CNN, but it just has more layers. So it's capable of understanding, modeling, and dealing with more complex data. So that's just that. It's not really there's no real fundamental difference. It just depends on your use case. Depending on how complex your use case is, you choose between like a deeper CNN or more shallow CNN.
Got you.
Does that answer your question?
Yeah. Okay. Got it.
Okay.
I'm
Okay.
gonna share the link in the chat box.
Thanks.
Presentation.
Cool.
Okay, then continue.
Okay, sure. So I'll move on to the next question now. In what sense is PyTorch on par with TensorFlow, or better than TensorFlow?
Yeah.
Okay, so that's a good question. I think it depends on what you want to do with the deep learning, but I would personally say if you're working, if you're still a beginner and you're independently working on projects and Kaggle and things like that, I would definitely say PyTorch is better for that kind of use case, because PyTorch has really good API, right? And it's really easy to learn if you're a beginner. It's super intuitive compared to TensorFlow. TensorFlow can be a bit confusing, compared to PyTorch. So I would suggest PyTorch for that, but TensorFlow is definitely known for more, industry based use cases.
Yeah.
Like for example, TensorFlow has a lot of really good functionality if you want to deploy a trained machine learning model on your phone, right? If you want to make a phone app that uses machine learning, you can use TensorFlow Mobile. But PyTorch also has those things, but it's not that good at that. So if you want to deploy things really well, if it's like more of like an industry oriented thing, then definitely I would suggest TensorFlow. But since you are just trying to independently learn machine learning and work on your own projects, I would definitely suggest PyTorch for that, because the general consensus is that PyTorch is for students and researchers, and TensorFlow is for like professionals and people in the industry. That's a general advice people give.
Okay. Yeah. Okay.
So for your use case, I would say learning PyTorch is definitely useful, and my personal opinion is also that it's definitely a lot better for people like us who work on Kaggle and work on our own data sets.
Okay. Yeah.
Okay, so I think that's it for the technical questions, right? Your last question is, what are the basic technical skills needed to become a data scientist?
Yeah, that's the last question. Yeah.
Um,
Technical in the sense, like that's the difference. Which tools we have to use for this data science to become good analyst or researcher?
I'm not sure if I'm the best person to answer that question, because I don't have any experience looking for data science jobs or internships. So I can tell you what skills you need to work on a specific data set, but I can't tell what skills you need to become a data scientist, because I'm still a student.
I can explain the skills like, for excellent data science to be good in data science.
Yeah. So my suggestion is there are three parts to the data science work. One is understanding the data sets, meaning that is the first step that any data scientist would do. When I say understand the data sets, meaning when somebody gives you a raw data of like say 100 GB or 10 GB, whatever the number is, you need to understand what the data in the first place. So able to visualize the data can be the first skill that I would suggest. You're not talking about modeling at this time, just to be able to visualize whatever the data set that you are given. That will be the step one. And the visualization will be the required skill set in that particular area. So there are very good Python packages there for visualizing the data sets. The second step would be able to model that data set. For that, of course, the required mathematics, the algebra and calculus would be quite useful. And the topics that we were discussing for the last few minutes around the deep learning basics will be quite useful. Able to come up with an architecture for a particular problem. When I say architecture, the deep learning architecture, what should be the data that need to be fed to the neural network, and how many layers of the neural network need to be there, and how do you train that? So the second step would involve the skills around modeling. That means the basics of algebra and calculus, as well as the required skill set for the deep neural network architectures. So deep neural network architectures, the architecture would be very different for each and every data set. So that's more of an art than a science. How do you arrive at an architecture which can actually model a particular data set? So the third one would be once the model is ready and it's all trained, how do you expose it to the users? How do you store that model, whatever you just trained? How do you upload it to a kind of a container, maybe Docker container, kind of an equivalent for users to actually use that particular model? So the third skill set I would suggest is maybe the concept of Docker containers would be quite useful for actually the users to see or consume the models. So to summarize, three major skill sets: one, visualization for on top of the raw data sets. Second step, the basics of mathematics as well as the basics of the neural network architectures. And the third one, I would suggest Docker containers. Does that help?
Yeah, it helps. Okay, got it.
Okay.
Like where can I find this? There are different type of neural networks now with architectures. Where can I find a lot of architectures? How they are used? Like where can I find them?
I think the best ways to discover new architectures is to just expose yourself or to just expose yourself on the Kaggle community. People are always discussing all sorts of architectures and all sorts of data sets.
Yeah.
Right, and if you just join different kinds of competitions, you can join a competition for image classification, for classifying images as dogs or cats, or you can join a competition for text classification, like classifying a sentence as happy or sad, something like that.
Yeah.
Classifying movie reviews as positive or negative. That's a text classification problem. That requires different kind of neural network architecture, right, compared to CNN. So you just expose yourself to different problems on something like Kaggle. You will automatically be exposed to different architectures, I would say.
Yeah, one more thing I would suggest is even going one step back. There are certain architectures based on CNNs, at least for you to get an idea about how an architecture should look like. For example, if you search for RESTnet 50, RESTnet some other number, those are the architectures that are available for CNN problems. When I say RESTnet 50, you would have 50 hidden layers. So if you have a different number, that number indicates how big of that particular neural network architecture can be. So, so similar to ResNet 50 and some other even bigger architectures can be the good starting point for you to know how a typical neural network architecture which is working, and for you to get an idea from. And then, as Tarun suggested, you can start modeling on your own.
Yeah. Okay. Like Tarun, can I ask some few doubts regarding the CNN hall? Like, can I ask some doubts? Like we have time,
Yeah, sure.
like few minutes.
Yes, go
Like,
ahead. Just
like from convolution layer to there is use of padding by without using padding, like we'll lose the data now.
can you repeat your question? You said that there's padding after the convolutional layers.
So without using the padding, like we'll lose the data. No, that's what happens now. We send the input data to our convolutional layer where we will use the filters, and from we apply the filters on the normal image instead of the padding image, and if we do that, we lose some data which
So
we pass.
so basically, you're asking if when we use padding after convolutional layers, then we discard some data. That's what you're saying.
Yeah,
Why
yeah,
do why do we do that?
yeah. And also, well, when we drop out, like when you use dropout layer, like there is a chance to lose some the data which we pass to the input layer. Like how will you handle with that?
Okay. I get your question now. So, yeah, layers like padding and dropout, we do lose information from the original image, but that is part of the purpose. The reason we do dropout is because we want all the neurons in the network to be trained properly. So, uh, the problem is sometimes when we train neural networks without dropout, right?
Yeah.
Some neurons handle most of the burden, and the other neurons don't really learn anything, or they don't really contribute anything meaningful.
I think there is a chance for overfitting. That's what I said.
Yeah, there's a chance for overfitting because not all the neurons are working and learning different parts of the data set.
Yeah.
So it's very limited understanding of the data set. But when you use dropout, right, you're forcing some neurons out of the equation completely on every forward pass, correct?
Okay.
So because of that, all the neurons are forced to learn something. They're all forced to handle some of the burden. So if I have 10 neurons, right, and the first time I drop the first 5 neurons, the last 5 neurons are forced to learn something. And then if I drop the last 5 neurons, the first 5 are forced to learn something. So it's like you're constantly shifting the burden from some neurons to different neurons, so that all of them get some training. And if you don't do that, then there's a chance that some neurons will dominate and the others won't do anything. And so all those extra neurons are just waste, right?
Yeah.
So that's why we do dropout. Even though we're losing, like you said, even though we're losing information, it's useful to make a more robust model.
Yeah.
Does that answer your question?
Yeah. Like, that's okay. Like, there are a lot of filters, in, well, vertical filter, horizontal filter, different type of filters are there. Well, when we train this like this model using CNN, the TensorFlow on top of Keras, we use that. It will choose automatically will choose the filters, or else you have to pass it to the model filters.
Oh, you're talking about, okay, the filters are randomly initialized at the start of training. They're just like any other weights. Think of filters as weights. You're talking about kernels, right? Kernels/filters. What you use to do the convolution.
Pardon? I didn't get you. Pardon.
Yeah. So when you say filters, you're talking about the matrices that we use to do convolution, right?
Yeah.
Yeah. So those are like weights. Think of them like weight matrices, like W matrices. We just initialize them randomly at the start, right before training.
Okay.
And then with every batch of images, we keep updating those filters. We don't know what the correct filter values are in the beginning, right? That's the reason we're training the model to find the best filter values for that particular data set.
So we will use the activation function on the fully connected layer, or else on the convolution layer.
That depends on how you design your architecture. I've seen people use activation function after every layer. People use activation function after convolution. They use activation function after fully connected. They use activation function at the very end of the network. It depends. That's up to how you design the network. But usually the convention is people use activation after both convolution and fully connected. So I've seen a lot of people design networks like convolution ReLU. So like after every convolution, you have a activation function, something like that.
Yeah. Okay, sir.
Do you have any other questions? Oh, that you want me to answer?
Yeah, I'm thinking just clean on me.
Okay, cool. So I think we can meet again the next session, which is like 3 weeks from now.
Yeah, okay, sure.
So I think, okay, so I think we did a great job in getting through these questions. And what do you think, Nani? You got satisfied answers for your questions?
Yeah, I'm satisfied with the answers, because like a lot of information he has given. Like I had to work on the basics and a lot of things, so that I can get a lot of confidence to ask more challenging questions.
Good.
That's what I
Yeah.
have to do.
Yes, absolutely. No question is a bad question. That is how it goes.
Yeah, ask anything.
Sure, then. Thanks for joining with us. And Hasni also.
No problem.
Thank you
Cool.
for
So
coming and
let's meet
asking.
again in 3 weeks. Take care, guys.
And any of your friends who missed this, you can just direct them to the link that we'll share so they can watch it again.
Yeah, sure. Like actually we have exam on Monday and Tuesday, internal lab exam, which is on deep learning only. Yeah, I'm preparing for that.
Well, I hope you do well in your exam, and I hope anything that that I answered today is helpful in your exam.
Sure, sure. A lot of your PDFs, everything are helping. I'm preparing all your presentations, like going
That's
through your
great
challenges.
great to hear that whatever I did is coming of use to you.
Yeah, thank you.
Bye, guys. Thank you.
Bye. See you next time, man.
Yeah, bye everyone.